Welcome back! Last time we saw each other, we discussed understanding mean, median, and mode. Remember? We analyzed the book club's data to find the number of books a typical club member read in April. We found the mode was 5, the median was 6, and the mean was 7. Let's see how the number of books a new member read influences mean, median, and mode, and get another problem solved. Here comes our new member, Sam. Talk about someone who likes to read.
Hey, Sam.
Will the mean, median, and mode change when we include Sam's books? Let's take a look. We'll start with the mode, the number that occurs most often. It was 5 before we added Sam's books. Will it change? The only way the mode will be different is if Sam read 9 books. Then 3 people would have read 5 books, and 3 people would have read 9. In situations like this, there are 2 modes, and the dataset is described as bimodal. It looks like Sam has read more than 9 books, so the mode will not change. Next, let's think about the mean. Ashley, the club's president, recalculated the mean with Sam's books included. It increased from 7 to 8. That didn't increase too much. How many books do you think Sam read in April? One way to determine the answer is to equalize. Since the new mean is 8, then Sam must have read 8 books, plus enough books to raise the mean. 8 plus 9 equals 17 books. Wow! Here's a second way to look at the problem. The club read a total of 63 books without Sam's. With Sam, the 10th member of the club, the mean is 8. Now the total number of books equals 10 times 8, or 80. The old total is 63, and the new total is 80. 80 minus 63 equals 17. So Sam read 17 books. Finally, will the median change? As you know, the median is the middle number in the distribution. When there were 9 members, it was easy to find. We now have 10 members, so there isn't one middle number. When there is an even number of entries, the median is halfway between the 2 middle numbers. The 2 middle numbers are 6 and 8. 7 is halfway between 6 and 8, so 7 is the new median. The median does change. Sam read 17 books. That's a lot compared to the others. In fact, when datasets have an extreme value like this, it is referred to as an outlier. What if Sam read 97 rather than 17 books? That would be an outlier for sure. But how would it influence the mean, median, and mode? Well, the mode wouldn't change, and neither would the median. But the mean would increase to 16 books. Which value, mean, median, or mode, do you think is most representative of the number of books read by a typical club member? In this case, the outlier of 97 significantly increased the mean number of books read, so it no longer represents what is typical. The median better represents the number of books read by a typical club member. In other situations, the mean is more representative. You can see why it's important to analyze all 3 values when evaluating data. I think that closes the book on understanding averages and measures of center, and that's another problem solved.